Nutrient cycling is the key to healthy soil. That's how a forest does it. How do we cycle those nutrients? What does that mean? Hello, George, Advantage Food Forest. I got a soil sample on a slide here under the microscope. I quite often talk about the soil food web. So I took a sample from out of my food forest on my pear tree, so we can have a look when I say bacteria and fungi and protozoa and different types of protozoa and nematodes and arthropods. Let's look and see how many of those things we can see in a good soil sample. I've had a look around. It's a nice sample. I've got a nematode up now. So we'll start there. We're out all the way out with the microscope now, looking at 40x, so 40 times magnification. That circle we're seeing in the center is the nematode. There's 5 types of nematodes: bacterial feeding, fungal feeding, root feeding, predatory, and opportunistic, I believe. I think I'm missing one there. We'll check me on that. Let's zoom in. This is one we can tell by the mouth parts. Oh, he just started moving on us. It just started moving on us. There we can see the mouth parts. We can see a little canal up where the mouth is. And that shows us it's a bacterial feeding. That looking at that mouth shape. There's a good view of it right there. You see the little canal where the mouth is and where the lips are. And if we zoom back out a little bit or in through the layers, there we see the bacteria. That's what he's feeding on. That's what it is feeding on. We tell these by the shape as well. There's going to be something zipping around there as well. These are going to be some dots and some rods that we'll see here. We don't want to see any Z-shaped ones. So the dots and the rods are bacilli and cocci. Those are great. Those are a decomposer. They're decomposing that organic matter. We'll also look for fungi in here. Let's take a better look at this nematode. We'll look down its whole body. Even inside of this nematode, we can see the bacteria that it's already consumed. I get a kick out of being able to see even the ribs on it. You can see just like an earthworm. It's a worm. It's a microscopic worm, but it's a worm. So when we talk about worm castings, they're very bacterial in nature. We'll find fungi in there, but the inside of them is generally the same as the inside of this nematode, bacterial dominated. You can also tell a male and female by their tail. And I believe this is the female. The male would have a longer, pointier tail on it. I think what I'll do is I'll pause here, and now I'm going to look for some. I'm going to pause here, and I'm going to have a look for other members of that food chain, that food web. So we're seeing the bacteria all over. Now let's see if we can see some fungi and some protozoa. Didn't even really have to move. Right there, we're seeing a shelled amoeba. So this is going to be a protozoa. So we have the bacteria and the fungi are the decomposers. And feeding on that are protozoa. Actually, this is a flagellate. Let me change the coloring a little. We'll see he's got a tail sticking out the back of it. So there's amoeba. There's naked amoeba and shelled amoeba. I thought this was a shelled amoeba. We'd see a shell around it. But I'm seeing a little flagellum, a little tail out the end of it here. We're just barely able to make it out every now and again. Little whip-like tail sticking out the end of it. Let's see if I can zoom in with a camera. Too much. Did too much. Just barely make out that flagellum sticking out the end of it. That's also feeding on these bacteria and these fungi around. I'm going to keep looking. Let me see if I can find a shelled amoeba now. There's a good look at a shelled amoeba. So again, there's the bacteria and fungi at the bottom of the food web. Then we have the protozoa. And in those protozoa, we have amoeba, flagellates, and ciliates. This is an amoeba. And with amoeba, there's 2 types. There's a naked amoeba and a shelled amoeba. You see the shell, it's a double wall going around the outside of it here. You see the mouth on this end. Probably see a few more in here. I don't have to go far. There's another one right there. And we can see the shell around it and its innards. These are organic matter in front of its mouth. We can see the shell on this one very well. Another type of amoeba, a very good sign, an excellent nutrient cycler. This is an Arcella amoeba. You get all around it. We can see all that bacteria and bacteria moving. Lots of bacteria in there. Nice healthy population. And another shelled amoeba. See how similar they look? The mouth on the bottom left. I'm real happy with this soil sample. There's another shelled amoeba. Testate amoeba. Mouth on the bottom right. That shell's coming out into the blue. See a really nice amount of bacteria in the background. Those dots and rods. The dots being the cocci and the rods being the bacilli. A real nice bacterial count in there. Also look for some nice segmented fungi, some septa in it, some breaks in it. Then you find something like this that you have no idea what it is. This has a fish shape to it. Or if it's just a piece of organic matter being broken down. Oh, and we can even see another amoeba in the background there. There's a fungal spore. Seen quite a few fungal spores in here. I'd like to see more fungi in here. Let's keep our eyes open, see if we can find some nice hyphae, nice long strands of hyphae in here. Here's some nice fungi. There's a nice brown color to it. We're called the septa, or the breaks in it. We'll see some nice breaks in it as we go down through. Each of those an individual cell. Got a pass nutrient between them. You see another one in the background there. Very nice long piece. Nice long piece. I'm not sure what kind of fungi it is. I'd assume it's a saprophytic fungi, a decomposing fungi. Those bacteria in the background. What it does, it excretes. It excretes a fluid around it, and that breaks down whatever it's feeding on, whether it's bacteria, organic matter, and is able to pull that fluid back inside itself. This testate amoeba, that's a different one. So I'm seeing a lot of these testate amoeba in here. That's a real good sign. They wouldn't be there if the bacteria and the fungi weren't there. You saw that nematode right off the start. We're seeing nice chunks of fungi in there. Another fungal spore that looks like a football over on the left. We can back off to 40x. And here we're going to see some of those acids I was talking about. That we're seeing I believe that's a humic acid, a little darker color. We'll see fulvic acid will be a little lighter color. Nice amounts of organic matter around like these. That's what the fungi and bacteria are feeding on. It's a big shelled amoeba there, I believe. Right there in the bottom left. Well, my slide's drying up, so I thought I'd take us back to the top. We see the nematode here we started with. Zooming in, seeing its mouth parts. Tell what type it is. Identifying this one as a bacterial feeder from that mouth. Ooh, real touchy at 400x. There we go. There we see that mouth. And in the background, we see all the bacteria. Of the three types, we only see the type that show us it's aerobic as in oxygen, seeing the dots in the rods. Seeing the dots in the rods showing it's aerobic. What we want has oxygen in there. If there was Z swimming ones, those will be spirilla, showing us it's gone anaerobic or on the edge of it. And we'll just do a quick look and see if we find a protozoa without zooming out. Oh, there's a flagellate right away. We'll see him here zooming, bouncing around a little bit. There he goes. Off of that flagellum. And there's a shelled amoeba. Another good-looking testate amoeba. Mouth is very obvious on this one. On that end. Okay, so in summation, we're talking about a healthy soil. If we look under a microscope, or if we know our soil is not healthy, we can achieve that with compost, thermophilic compost, regular compost, compost teas, adding organic matter, cover crops, combinations of these things. But what we've seen in the video is that cycling of nutrients. We tend to see things in a end game or an end results. There's only so much nutrient there for that tomato and those marigolds out in front of it. That's not how nature works. It's always cycling those nutrients. All those solar collectors are collecting all that energy, and we're cycling that energy. A lot of that's being returned to the soil. We're taking some of our fruits out of there, but as long as we leave that organic matter to be broken down, what we've seen under the microscope is all those animals feeding on one another, defecating, decomposing, and all that is cycling those nutrients. So as that organic matter falls to the ground, as those enzymes are released from those plant roots, those bacteria, fungi, protozoa, microarthropods, nematodes, and arthropods, feeding on one another in that organic matter, cycling those nutrients. We also want to make sure that we don't have bare ground. So again, if we end up doing a harvest, mulching it, putting leaves on it for the winter time, or even better yet, if we can get cover crops in there in time. Once those microbes are there, those cover crops release those enzymes that they're sweating out enzymes through the root system and feeding those microbes, cycling those nutrients, keeping all of that going. So having more solar collectors, the better. Hope that makes sense. I'm George. Fat Ninja Food Forest. Change can be better than a holiday and is long overdue. Peace.